In this video, we're going to be demoing Lab 7. We're also going to be creating the first part of it. So this is part 1. In part 1, we are going to use a NAND gate. This is a NAND gate, and you could tell by the numbers, the code, 7400. And we're going to use this NAND gate and make the equivalence of this NAND gate by using this NOT gate paired with this OR gate. So these two together, if we wire it correctly, is going to give us the same output as this NAND gate. And we're using this NAND gate just to compare the results. So we're wiring these two together, and then this is going to be next to it to compare. Currently on my breadboard, I have the power supply right here, and it's connected. So if I were to flip this, it would turn on. But from previous labs, we have this previously set up. We have the power either going in from this top rail or this bottom rail. One of them is power and one is ground, so you want to make sure that's connected correctly. We have this resistor right here, and we can see that it is one column away from our switch. And then we have these two wires that are going out from our switch, and one is connected to one and the second is connected to the second switch. So that is the entire left side. Now these are just power and ground for the gates that we will be connecting. So these do nothing at the moment, but they will be powering and then grounding the gates. This right here is just grounding this resistor with our LED bar so that we don't break it or anything. That is the current circuit, and well, it's technically not a circuit yet, but we will be building one. So what I'm going to first do is I'm going to have the NAND gate set up, and it's going to be, again, set up by itself because it is a NAND gate. And then after this is set up, we are going to prove that this NOT to OR gate is equivalent to a NAND gate. So to hook up a NAND gate, we have one input in the first leg and we have a second input in the second leg. The output, if we hook these up like this, it's going to be in the third leg. So to connect this output, I'm going to use the red wire, and this red wire is going underneath the third leg, and then it is going into the power strip. And this is actually too short. So coming back with a longer wire, we're going to see that we can connect it into the third leg right underneath it. And then we are going to just connect it into any of these, make sure it has the resistor on top of it so we couldn't use this last LED, for example. And I will just connect it into this one. Again, it doesn't matter the specifics. The only thing that's specific is this side right here. Now that this is wired up correctly, we can actually test it. So I'm going to turn on the supply. It was already pushed down, but we can see that the NAND gate is lit. And the NAND gate, when our switches are 0, 0, is 1. And if our switches are 1, 0, it is still 1. The only time when there is no output is when they are both on. So we'll test this. We flip the first switch, it's on, and what we should do is to make sure we're actually flipping this first switch is wire our first switch. For this, I like to use white wires or black wires for neutrality, and they'll just go in. And you should also turn this off before you start connecting and disconnecting things. That would be very, very smart, which I am not sometimes. So we'll turn this back on. If we flip the first switch, we can see that it is flipped. And all I did here was I connected these wires to the ones coming out of it. So it's not interfering or getting anything from this gate. It's only getting from the switches. If I turn this off and turn the second one on, we can see that it's still lit. And then if I flip both of them up, we can see that it turns off. So our NAND gate clearly works. I'm going to take these two out. And that was only just to see that our first and second were going into the first and second of the LED. Now we're going to hook up our other gates. Remember that this wire right here has to be connected to the last leg. That way it is having power or it's grounded. And one side needs to be connected to the blue and the other side needs to be connected to the red, negative and then positive. After these are set up, we're gonna bring these two in. We can really put them anywhere, just make sure it is connected, as we said, with the ground and power. So I'm going to connect, this is the NOT gate. The NOT gate goes first, the NOT gate goes right here. And it's not gonna be interfered with this NAND gate. This NOT gate is by itself, but paired with this OR gate. So we have a NOT gate and we have an OR gate. Also, I made an error. when you put your gates in here, you want to have this little notch facing to the left or facing your switch. So it's supposed to be facing this way. We can see that this one is not facing that way. It's facing the wrong way. So all you got to do is pop this out and then turn it around and slot it back in. So that is the proper way to insert these. Now we're going to hook up the NOT and the OR gates together and then give the output. So this is the NAND equivalent. To do this, we are going to get power from our switch. So to get power from the switch, I'm going to use this orange wire. We're going to color code everything so it's super easy. This first switch, it's going to go in here. They're in the same column. And then this is going to go into this gate, this NOT gate. We're hitting the NOT gate first, and then we're going to the OR gate. And that should be clear through the diagram. We go through the two NOT gates and then through the OR gate. Now, you might be thinking to yourself, why are there two NOT gates in the simulation, but only one NOT gate here? That's a good question. And the answer to that question is that, if you didn't already know, is that these gates give multiple outputs depending on how they're wired up. And we're about to demonstrate that as well. So for this gate, this NOT gate, for my NOT gate specifically, I found mine to be a little bit weird and it wasn't 100% correct with the diagram. But you can play around on a different breadboard with the actual inputs and the outputs. Remember that a NOT gate only takes one input. So we are going to take this wire that's going from the first switch, and then we are going to put it into the underneath the first leg of the NOT gate. So it's going to slot in like this. It's underneath the first leg. The output of this is going to be underneath the third leg. So you're going to leave one gap between them, and it's going to slot in just like this. Now, the output for this gate, this NOT gate, because remember, this wire is input and this one is the output. Output is going to go into our OR gate, and we'll just put it into the first one. So that's the output for our OR gate. So that's the input for our OR gate, output for our NOT gate. This has been wired up, and that is one of the inputs for the OR gate. Now we're going to use the same NOT gate to get a different output here. How we're going to do that, I'm going to do in green. And for this, we're going to use one of the other sets of this NOT gate. Again, you might have to play around with it if your gate is different, but this is what my gate looks like for the NOT. The NOT is in the middle. And for this one, I'm just going to hook it up to one of these switches. I'll slot mine down here. And once it's in this column, what I'm going to do is I'm going to bring it over the top like this. And then I'm going to plug it into the third to the last to the right of my gate. And so it'll look like this. We'll see two gaps with the legs right here. That's what that's going to look like. That is the input for this part. We have two inputs and we're going to have two outputs. They're separate. The output, because this is again the input part, is going to be one away from it at the very end. So it's going to go in right here. Again, we're going to have one slot away from it. So this wire is now the output. The output is going to go into our OR gate, and it's going to slot in to the second slot like this. Because for our OR gate, we have slot 1, slot 2 as inputs, and then the third slot is an output. For the output for this gate, I'm going to just use a yellow, and this OR gate we can connect into the third slot, because like I said, it is the output. We're going to wire it right behind the actual NAND gate, because remember, what we just created is an equivalent to a NAND gate. And NOT followed by an OR is equivalent to a NAND gate, and this first one is just a NAND gate. So that would be the circuitry for that. Now we want to see our 1 and our 2 powered on. So what we can do here, since it's pretty crowded right here, we can't really connect anything in here to have it go to the switches. We can just find the inputs before they hit the gate and then just connect them with that. So for this first orange wire, we know that this is an input. We are going to plug this in here to piggyback off of the first switch. This is the first switch. And actually, if we wanted to piggyback off of this, we would have to change the column that this green one is in, because currently we can see that they are both in the first switch. And to piggyback off of the second switch, this is going to need to be in the second switch. So now it will look like this. It will still be connected, but just one switched over, and that is not a big deal. So now this first green wire is the input for this NOT gate, and since it's the input, we can connect it just like this. And then we know that this is the second, green is the second, we'll connect it to the second LED. So this is what our final circuit is going to look like. We have all three of our gates in the middle, wired up, and that is the wiring for them. We can see that all the switches are off. That's how we're starting this. All of the LEDs are off. And now what we're going to do is turn this on. In turning this on, we can see that both of our outputs for the NAND gate light up. And if they both light up, that means that you did it right. Congrats. That's pretty cool. Because when the inputs for the NAND gate are 0, 0 or equivalent to 0, 0, the output is 1. If we flick the first switch up, that means we have 1, 0 for the input. Our output is still going to be 1. If we flip this first switch down and then flip the second switch up, we can see that the second switch is on, and then we have the two NAND gate outputs, and that's how that would work. If we flip both switches up though, we have 1, 1 for the input, we will have a 0 for the output, because a NAND is basically the negative or opposite of a AND. You can think of them like that. And that is how you would go about doing the first part of this lab. This is the circuitry, and this is both NAND gates demonstrated. To demo this lab, you would basically just go about flicking the switches, explaining the inputs as being 1, 0, 0, 1, 0, 0, or 1, 1, and then demoing the results and showing the equivalence here. That's how you would do this lab.